Unlike parallel lines, perpendicular lines do cross. They only cross at one point, and they form a special angle. They form a perfect right angle. We can identify perpendicular lines by looking at their slopes. Just like looking at parallel lines, we identified them by looking at their slopes. We can do the same for perpendicular lines. This time, instead of looking for equal slopes, we are looking for slopes that have negative reciprocals of each other. So let's review what reciprocals are. A reciprocal of the number 8 would be 1 over 8. But we don't just need reciprocals, we need negative or opposite reciprocals. So if you look here at the example negative 2 over 3, the opposite reciprocal of negative 2 over 3 is positive 3 over 2. The example 5, remember every whole number is actually a fraction over 1. The opposite reciprocal of that is negative 1 over 5. Another trick that you can use to identify whether they are perpendicular is take the slopes and multiply them together. The product of slopes of perpendicular lines will always equal negative 1. If I multiply negative 2/3 times 3 over 2, I will get negative 1. Negative 2 times 3 gives me negative 6. Positive 3 times positive 2 gives me positive 6. Negative 6 divided by 6 equals negative 1. Those are negative reciprocals of each other, and I multiply them together, I get negative 1. Those must be the slopes of perpendicular lines. So let's look at these two perpendicular lines. So these lines intersect and form a right angle. If we look at the red line and we want to see what the slope of that line happens to be, let's take a look at it and see what that slope is. If we go up and back, we went up 1 and over 4 in the negative direction. So the slope of the red line was 1, negative 4. So what's the slope of the blue line then? Well, the slope of the blue line, let's use, let me see, what would be a good point? I'm going to start right here. I'm going to go up 4 over 1. Well, both of these go in the positive direction. So this slope is 4 over 1. Notice how they're opposite of each other, and one is positive and one is negative. So they're flipped over and they're the opposite signs. So perpendicular lines have negative reciprocal slopes. And the product of slopes of perpendicular lines is equal to negative 1. So that is how you can tell if you have perpendicular lines. If their slopes are negative reciprocals of each other, and if you multiply their slopes together, you'll get a product of negative 1. So let's look at these three lines and figure out what the slope of the line that would be perpendicular to that line would be. In this particular line, y equals 2/5 x minus 8, the slope of this line is 2/5. So the slope of the perpendicular line, and here's a new symbol for you to learn. This is the symbol for perpendicular. Perpendicular is a pretty big word to have to write out over and over again, so we just use the symbol. It's an upside down T. I don't know why it's a T, but hey, we're going to use it. I think it's because it's a perpendicular line, but that's the symbol for perpendicular. The perpendicular slope for this line would be 5 over 2, and it's got to be the opposite sign, so it's negative 5 over 2. How hard was that? So the slope of this line is negative 1 over 5. The perpendicular slope would be flipped and the opposite sign. So it's going to be positive. Now we don't write the positive, but I just put it there just to make a point that it's going to be the opposite sign. In this line, the slope is negative 2 over 1. The perpendicular slope is 1 over 2. It's positive because the given slope is negative, and the perpendicular slope is always the opposite sign. To determine if two lines are perpendicular by looking at the equations, it's just what I said a few moments ago. Put both equations in y equals mx plus b form. There's that y equals mx plus b form again. I told you, you're never going to get away from it, so it's best to go ahead and practice it now. Compare the slope of each equation, just look at the m, and determine whether the lines are perpendicular by determining whether the slopes are opposite signs and flipped values. Let's give it a try. Determine whether these two lines, if they were graphed, would be perpendicular. Convert both equations into y equals mx plus b form. This one is already in y equals mx plus b form, so let's just convert the first one. The 2x needs to be relocated to the other side. So 3y equals negative 2x plus 4. I need to divide through by 3. So now I'm in y equals mx plus b form. Let's look at the two equations closer together. And let's compare the slopes. Well, one's negative and one is positive, but they aren't flipped over. They both have 2 on top and 3 on the bottom. These are not perpendicular. In order for them to be perpendicular, one would have to have the 3 on top and the 2 on the bottom. So these are not perpendicular. Let's give the next one a try. Why don't you pause the video, try to solve it yourself, and come back and see if you get the same answer as me. I am converting this one to y equals mx plus b form. I'm going to move the 3x to the other side. I need to divide everything by 4. And compare their slopes. In the first equation, I have negative 3/4, and in the second one, I have positive 4 over 3. Yes, they are perpendicular to each other because they are opposite and they are reciprocal. They are opposite signs and they are reciprocal. So you have learned in this lesson all about parallel lines and that they have the same slope and they'll never touch. And you've learned about perpendicular lines, that their slopes are flipped and they have opposite signs. Challenge question for you. What's the slope of the line that is parallel to x equals 4? If you don't know what the graph of x equals 4 looks like, look it up. Do a little research. See what you can find. And then see if you can answer the question. And what is the slope of the line that is perpendicular to x equals 4? I wonder what that looks like. I'm thinking you're going to have to look that up. And you're going to have something to do with maybe undefined slope or zero slope. I don't know. We might have some horizontal lines or vertical lines involved in this question. Look that up and have that information ready to talk about the next time we meet in class.